Limits, an intuitive approach, part 4. Here we have the limit of a rational function as x approaches 3. It's a two-sided limit. And the first thing you try with a rational function like this, or any function really, you just plug in 3 and see what happens. Unfortunately, when you do that, you get 0 on the bottom and 0 on the top, and this is one of our indeterminate forms. So we're kind of forced into making some kind of a change to this function. Maybe we can manipulate this algebraically and figure out what's going on. And that's what I'm going to do. I noticed that the top factors, and when the top factors, I can see, oh, well, look, I can cancel something out. This rational function wasn't reduced, so it had a hole. In fact, it had a hole at x equals 3. And when I reduce it, I end up with 2x plus 5. And now I can plug in 3 with impunity. In other words, this will work fine. The idea is that this 2x plus 5 has the same points on it. Y equals 2x plus 5 has the same points as y equals 2x squared minus x minus 15 over x minus 3. Okay, all the points are the same except at 3. But we don't care what happens at 3. So if we know where this function is heading, then we know where this function is heading. So I put in 3 and I get 11. And therefore this limit that I started with that gave me 0 over 0 actually gets closer and closer to 11 as x heads to 3.